Hello there. Hope everyone is doing well, that you're having a great day. Today we're going to be talking about Module 38, which is Assessing Intelligence. So in the last module, we talked about different theories of intelligence and how to define it. Now we're going to talk about how can we actually try to measure intelligence. So let's go ahead and jump right into it. All right, so what exactly is an intelligence test? It is something that we use to assess an individual's mental aptitudes, meaning like their mental abilities, their capabilities, and comparing them with those of others in a numerical sort of way. So basically, you're just trying to quantify and measure in some sort of way individuals' intelligence levels and then compare those to other people as well to kind of help you decide exactly what your scale of intelligence is. Um, so basically, there's kind of two main categories of intelligence tests that we have. Either they are achievement tests or aptitude tests. Achievement tests are intended to reflect what you have learned, so they want to kind of measure what do you already know, whereas aptitude tests are intended to predict your ability to learn a new skill. So they're trying to figure out how well can you probably do something. So let's look a little more at the difference between the two. Again, achievement test is something like an exam that covers what you've already learned in this course, for instance. So the AP exam, any of our unit tests that we have, final exams, those are all examples of achievement tests. So basically any kind of like traditional test you might think of, like in school, for instance, trying to get at what have you already learned. An aptitude test on the other side is something like a college entrance exam, where it's trying to predict how well do they think you could do in college. It's trying to predict your ability to do college work. So, for example, we have like the SAT, which, by the way, is the Scholastic Aptitude Test. It's literally in the name, or the ACT, and those are things that kind of help to try to predict how they're trying to predict what your abilities at college might be like, how well you could probably do in college. Also, any kinds of tests that are designed to help you predict or like figure out what job would be best for you. Those are all things that are trying to measure how well you could probably do at something. So definitely make sure you know the difference there between achievement versus aptitude tests. We're gonna skip past this here. So first big question for you, which of the following is the best example of an aptitude test? This is something we just gave an example with. That would be letter C. Taking an ACT test for college admission. That is aptitude, trying to predict. So by the way, just so you know, letter E, talking about discussing what you might study in college. That is potentially looking at like the future and what you might be doing, but that's not actually saying they're taking any kind of test. So that's why that one would not be the correct answer. It's just kind of having a conversation. All right, so take a moment to look at this graph here. Think all the way back to Unit 1, trying to understand graphs and correlations and everything. And we're trying to see here on our x-axis, we have SAT scores. On the y-axis, we have intelligence scores. Take a moment, try to remember for yourself, what kind of correlation is this? Is it positive? The variables are going in the same direction, either both up or both down. Or is it negative? One goes up, the other goes down. Either way like that. And then also, does it seem like a strong correlation, meaning it's close to either positive one or negative one? Or does it seem like there's no correlation really, which is closer to zero? So this will be an example of a pretty strong positive correlation. As your SAT scores are going up, as you're moving in this direction, your intelligence scores are also going up. They're both going in the same direction there. So that would be a pretty strong positive correlation. I can't tell you exactly what the number correlation is just from looking at it, but you can generally tell that's pretty strong. So the point of that is to show you that there's research that suggests there's a strong positive correlation between our SAT scores and intelligence scores. So a lot of people tend to consider the SAT as actually more of an achievement test. Remember, the purpose of it is to be an aptitude test to predict how well you'll do in college. But a lot of people today say it's kind of more an achievement test of how well have you been doing in your classes throughout your life and everything, how much knowledge do you currently have to be able to answer these questions. So it's more measuring how well did you do in high school instead of your preparation for college. So that's just a little tricky and something for you to think critically about. If you're asked what kind of test is the SAT, that should be an aptitude test. That would be your correct answer there. But just trying to think a little further than that, sometimes it kind of seems like maybe it's more of an achievement test today. All right, gonna skip over that too. Feel free to take a look back at these in the future or in the future on your own. These are some names that you definitely need to make sure that you know here. Galton, Binet, Terman, Wechsler, Stern. So make sure that you know what these different people did in the field of assessing intelligence, how they're different from each other. So let's talk about some of them now. Um, our first person here we're going to mention is Francis Galton, and he was fascinated with measuring human traits. So, fun fact, which you might kind of be able to pick up in this next statement I'm about to say, he was cousins with Darwin, Charles Darwin, if you remember him, the survival of the fittest, your adaptation, all those kinds of things, natural selection. Those were all Darwin's ideas. So Galton was his cousin. And one thing that Galton wondered is if it might be possible to measure your natural ability and then encourage those of high ability to mate with one another. So it seems like his intent was kind of good there of can we measure ability? However, he obviously kind of had that same mindset as his cousin Darwin, who was saying, how can we kind of find like the fittest people to survive and pass on their genes? So maybe not so much a ethical idea here of trying to pick the best traits for people to mate with. But he did devise certain methods to measure intellectual strengths based on things such as your reaction time, sensory acuity, muscular power, and body proportions. So those are just some of the different ways he tried to measure intelligence. However, his attempt to try to measure a very simple intelligence did not really work. The measurements he used, none of that really correlated with intelligence. So Galton was kind of our first person who attempted to measure intelligence. That's the big takeaway you should have from him. First attempt to measure intelligence. However, it didn't go very well. But he did make some other important contributions to the field of psychology, certain statistical techniques that we use. He's the one that kind of coined that phrase, nature and nurture. So, that's definitely a big thing to credit him with. And the belief in the inheritance of genius. So, a couple of things he definitely contributed to the field, but his measurement of intelligence was not one of them. So then we move on to Alfred Binet. And he was a French psychologist who the French government commissioned to try to develop a fair and unbiased intelligence test because they wanted to try to measure the abilities of French school children. They wanted to try to see, like, maybe they all shouldn't be at the exact same place in the same classes and everything. We want to try to measure their different abilities. So the French government hired Alfred Binet to kind of develop this intelligence test there. And he did, in fact, do so. So, your big key thing that you should remember with Alfred Binet that you should take away is that he did actually develop the first intelligence test. So, Galton was the first attempt to try to measure intelligence, but it didn't work. And Binet actually developed the first intelligence test. So, his idea and his student, Theodore Simon, they began by assuming that all children follow the same course of intellectual development, but there are some who might be developing more rapidly than others. So, for example, as they put it, dull child should score much like a typical younger child, and a bright child should score like a typical older child. So, everyone's kind of developing in the same way, but then there are some that maybe don't develop quite as quickly. So, they're on the dull side of the scale, and then the ones who develop quicker are on the bright side of the scale. Again, their words. So they then decided that their goal was to measure each child's mental age, which is the level of performance that is associated with a certain chronological age. So definitely want to take a moment to make sure we know what these terms mean. Chronological age is saying what is the actual number of age that you are right now. So if you were born in the year 2000, right now, you would be 21 years old if you've had your birthday. So if you were born in 2010, you'd be 11. So like, what is your actual physical age? That is your chronological age. Your mental age is what is your age based on your abilities rather than how old you actually are. How it's more like how old is your brain and your mental abilities instead. Like, what are your capabilities you have? So, an example of that, Benet was assuming that the average 9-year-old, 9 would be their chronological age, that they have a mental age of 9. So that means that their chronological and mental age add up. So that's your average child. They're the same thing. Children with below average mental ages, such as 9-year-olds who are performing at the typical level of a 7-year-old, would then probably struggle with schoolwork that's age appropriate for 9-year-olds. So even though the child has a chronological age of 9, Benet would say they have a mental age of 7. There's kind of your example there to be able to see the difference between the two. So how did he test then for mental age? So Benet and his student theorized that mental aptitude, again, like your mental ability, just like athletic aptitude, is a general capacity that shows up in various ways. So they tested a variety of reasoning and problem solving questions on Benet's 2 daughters. So he did use his own children to do some studying here, which isn't always the best idea for research when you use your own children. However, it definitely sparked some good ideas here. So he had his children, his 2 daughters, kind of answer some questions, and then also had some bright and backward Parisian school children attempt these same questions. Again, don't love the word choices here. They definitely have some detrimental labeling aspects to them, but just want to present the way that it was done. So then the items that were answered correctly could predict how well other French children would handle their schoolwork. That's how they're kind of using this as an aptitude test. So Alfred Binet, he was trying to kind of make that first intelligence test, which he did have and was definitely something that was like widely recognized and everything. But then we have someone named Louis Terman, and he was a professor at the of Stanford University. He then took Binet's test and modified it a little bit more so that we could use it as a numerical measure of inherited intelligence. So he took some of Binet's original items on his test, he added some, changed them a little bit, and then he established new norms for certain ages. So then he also extended the upper end of the test's range from teenagers to superior adults. So it could go potentially like even higher with your abilities there. So this version now today that we still know is called the Stanford Binet version. So the Stanford Binet is actually not the one created by Binet, but it's where the ideas were all taken from, and it's the modified version. But Louis Terman is actually the one who created the Stanford Binet test. And again, still used today. So this intelligence test revealed the intelligence with which a person was born. So not necessarily looking at aptitude, but like, what do you have currently? All right, so here's an important equation that you do have to know. In psychology, we don't really have too many mathematical things that you are responsible to learn. However, this is one of those that you definitely do need to know. And by the way, on like the AP exam and any tests we do in class, you are not allowed to have a calculator. So therefore, you need to make sure you can mentally compute these things. Ideally, any number you get on a test should be something that's relatively simple enough you can figure out without needing a calculator. So keep that in mind. So we have our German psychologist, William Stern, another one of those names you should know. He derived that famous term you've probably heard before, IQ, which stands for intelligence quotient. And the way that this is calculated is by taking a person's mental age divided by their chronological age, and then you just multiply it by 100 so that you get rid of the decimal. So here's your equation if you look at it right here that is listed there. So IQ is your mental age, which is MA, over your chronological age, CA, times 100. So if you are someone who is 10 years old, that's your chronological age, but you are showing skills at the level of an 8-year-old, that would be your mental age, you would do 8 divided by 10, which would be zero point 0.8, and then multiply it by 100. So that means you're just moving the decimal over 2 places. So that would then be 80. That's what your intelligence score would be. So you do 8 divided by 10, zero point 0.8 times 100 is 80. So that is how IQ is calculated. So something else important to know is that on our contemporary intelligence tests we have today, the average score for an IQ test is 100. So 100 is the average score for an IQ test, and that's an important number to know. That way some other things make sense as you're trying to figure out if things are below or above the mean, that kind of idea. So what are some limits that we had with calculating IQ? Initially, that formula worked pretty well for children, but it stopped working super well for adults. And think about it, because with children, you have a lot of really rapid development that's happening. But by the time you're an adult, it's kind of relatively stagnant. You are still developing, but not in the same drastic way that you are as a child. So a lot of current intelligence tests, like the Stanford Binet, no longer compute IQ using that formula there. But you do need to know that formula, so make sure that you're familiar with it. I'm going to skip over this one too. Feel free to look back at that slide. So what were some of the problems with our early intelligence tests? One issue is that if they were making like sweeping judgments just based on what these scores were saying, that was then an embarrassment to those who really championed their testing. So just kind of making too big of generalizations from intelligence tests. Lewis Terman came to appreciate that test scores reflected not only people's innate mental abilities, but also their education, native language, and familiarity with the culture assumed by the test. So basically, they're saying that initially they're kind of attempting to just capture how smart is someone, for lack of a better term. But then they came to realize it's not just like, what are your natural abilities? There are other things that come into play too, of cultural factors, your education, all those kinds of things. Definitely another huge issue is that there were abuses of the early intelligence tests when they were used for situations such as immigrant screening, when they're trying to decide should someone be able to come into the country or not. That's definitely not necessarily an accurate way to be able to decide should someone be able to enter your country. So definitely an area that you have to be cautious about when you're kind of using these kinds of tests like that. So now we are moving on to the intelligence test that David Wexler designed. And this is the big one today. This is the one that is really most widely used today. So psychologist David Wexler created what is now the most widely used intelligence test, the Wexler Adult Intelligence Scale, and that is abbreviated WAIS. He created that along with a version for school-age children and another one for preschool children. So if you see those other abbreviations, WISC or WPPSI, that's for children or preschool-age children. But the Wexler test is really our big one that's used now today. So what are kind of some of the things that they look at on this test? If you can recognize similarities amongst like patterns, vocabulary, letter and numbering sequencing, block designs, like kind of here, like where you're trying to use 4 different blocks to make this image that is shown right here. You have to kind of spatially figure out and kind of compute how these things go together. So by the way, in class, hopefully we can maybe try a couple of sample questions for a intelligence test, just so you can see what kinds of questions are asked. But also just want to make clear, if you ever go online and take an intelligence test, the ones that are found online are hardly ever ones that are completely reliable. They're not necessarily the ones that are accurately measuring your intelligence. So I wouldn't just go by a random test you'd find on Google and then say like, well, this is my IQ. They're like official tests and everything. So, and you do have to pay for like the Wexler test. So keep that in mind. All right, so here is a difference with the Wexler Adult Intelligence Scale from the Stanford Binet test. The Wexler test not only gives you an overall intelligence score, but also individual scores for each of those categories, like verbal comprehension, perceptual organization, your working memory, and your processing speed. So big differences between these individual scores can then kind of give you clues to where maybe your strengths or weaknesses are cognitively. So that's kind of the idea of, let's give you an overall picture of your intelligence score here, but then let's see specifically which areas you did best in and ones that maybe aren't your strongest suits. So like a low verbal comprehension score combined with high scores on other subtests could indicate that maybe you have some kind of reading or language disability. So they can kind of use those to break down more specifically where different strengths or areas for improvement lie. All right, so now we got to think about what are 3 criteria that an intelligence test must meet to be accepted. And these are 3 things that are super important, and you definitely need to know each of them. The first is that the test must be standardized. And to be standardized, that means you are comparing scores to a pre tested sample population. So you're not just having someone take the test and, like, okay, that number is that number. You need to kind of have your baseline. And that's what standardization does, is it gives you that baseline to compare scores to as you're trying to decide exactly how to score something. The next is that it must be reliable. And we kind of briefly mentioned reliability and validity back in Unit 1, but you definitely need to make sure you know these 2 terms. So reliability is the test giving consistent results? So automatically associate reliable with consistent. Are your results consistent? So I remember, like, R for reliable, R for results, and then the results have to be consistent. So no matter who is taking the test, on what day you take it, where you're taking it, you should score relatively the same thing every single time. If you're scoring totally different things, that is not a reliable test. And then finally, validity. The test must be valid. So validity is if the test is measuring or predicting what it is intended to measure or predict. So it's kind of similar to like accuracy, but not always necessarily. That's just kind of an easy way to think of it. But basically, is it measuring the thing it's intended to measure? And I just want to make sure that I emphasize, please make sure you know the psychological definitions for reliable and valid, because it's not necessarily the same way that you would use those terms in everyday language of, like, that's a reliable person, or that's a valid point. It's not really the same thing as that. So I would make sure you definitely know those, the difference between those 2 terms there. All right, so looking first with standardization, look at this. Remember, it is coming back. We are looking again at the normal curve, sometimes also called a bell curve because it's shaped like a bell here. So hopefully this is kind of starting to ring some bells for you. This is if you try to graph like test taker scores, usually we see that the scores then tend to form this bell curve, this normal curve. So you can see here that it's describing the distribution of many physical and psychological attributes. So remember, with a normal curve, that most of your scores fall near the average. And we said the average for an IQ test is what? It's 100. Awesome. So that's why 100 is in the middle here. That is your average, or otherwise known as your mean for IQ tests. So most of our scores with a normal curve tend to fall near that average, and there are fewer and fewer scores towards the extremes. So you can see how there's not very many when you get to the lower extreme and not very many when you get to the higher extreme. Hopefully this is all ringing a bell for you. Get it? Bell curve. All right, so please try to remember that in this normal distribution, the mean, again, is 100, but also if it's a normal distribution, that means that the median and mode are also the same thing. So if you see a normal curve and your number in the middle here is 100, that means your mean, median, and mode are all 100. All right? Whereas if it's skewed, that's when your mean starts to get pulled one direction or the other. So again, if we're looking at our standard deviations and everything, hopefully this is familiar to you, that we've got 68% of our scores that fall within 1 standard deviation from the mean. So again, if 100 is your average, 1 standard deviation below is 85, and 1 standard deviation above is 115. So that means that the amount of the standard deviation is 15. That's the difference between from 100 to 115, that's 15. And from 100 to 85, that's 15. So one standard deviation above is 115. If you add another 15, two standard deviations, that's 130. Another one is 145. So 68% of your scores are falling between one standard deviation above and below. Then 95% of your data is falling within this blue and green color here. The majority is here. So 95% of your data falls within two standard deviations of the mean. So most people are tending to score between 70 and 130. And then 99% of our data falls three standard deviations from the mean. So between 55 and 145. But our most common score is 100. So what does that indicate for both the Stanford Binet and Wechsler scales? A score indicates whether that person's performance fell above or below the average. So if you got 112, that means you're above average. If you got 72, below average. And so then how is an intelligence score derived using the normal curve? So a performance higher than all but 2% of all scores earned an intelligence score of 130. So you can tell that 2.5% of your data is above that second standard deviation here, but most is below that. And then a performance lower than 97.5 of all your scores earns an intelligence score of 70. Okay, so back to standardization. Again, that's our normal curve is helping to establish that. So in order to keep our average near a score of 100, they have to periodically re-standardize those Stanford Binet and Wechsler scales to kind of, keep up with the times and everything and make sure that they're still accurate with their average being 100. So for example, the fourth edition of the Wechsler scale was standardized on a sample who took the test during 2007, not to the initial sample from 1930, because those could be very different scores. Because, as we see on this next slide here, there's this little phenomenon called the Flynn effect that is saying that intelligence test scores and intelligence performance has been improving over time. So if you look at the data from like 1930 versus now, we see an improvement in our intelligence scores. So with each generation, it tends to get higher. So that's called the Flynn effect because of the researcher James Flynn, who first kind of tried to figure out its magnitude there. So in 1920, the person's intelligence score on average was, by today's standard, if you compare it to today, a score of about 76. And now we know our average is about 100. So clearly we are improving. And there are lots of different reasons for why that's happening. One thing being we have new technology and new science and everything. So we are learning more in general and have the ability to learn more things now. Also, education is a huge factor. Like back in the day, a lot of women did not attend school, but now we have women who are attending school in addition to more widespread education for all and a longer amount of time you're in education. Also, things like having better nutrition throughout the years. People are healthier. And so when you're able to meet those basic needs, that's when you can then, push towards that higher side of learning more things and everything. So lots of reasons that can kind of contribute to why we're seeing this increase in intelligence over time. All right, moving now to reliability. Again, you're trying to see, does a test give you consistent results? There are three ways we can determine reliability: either split half, alternative form, or test retest reliability. So split half is where you look at the scores on two halves of a test. So for example, say there's 50 questions on it, you might look at all the odd numbers, so 1, 3, 5, up to 50, and then all the even numbers, 2, 4, 6, 8, and you compare people's scores on the odd and even and see if they came out to about the same score there. If they're totally different, then that means your test probably isn't very reliable. Alternative form is you're looking at different versions of the test, so things that are generally getting at the same kinds of questions, but not the exact same question. So you're comparing if those kind of give similar results. And then also test retest is when the exact same test is given at a different time. Like basically you take the test again and they compare those results and see if you get the same score or not. So the higher the correlation between the two scores, the more reliable the test is. That means that if you're getting closer to the same scores every single time, it's more reliable. Quick question. If the same test yields consistent results upon retesting, it can be said to have a high degree of, hopefully, since we just talked about that, you were able to realize it's A, reliability, consistent results. All right, and then finally on to validity. That is the extent to which a test measures or predicts what it is supposed to. So an example here, if your environmental science teacher spent several weeks discussing global warming trends, then gives you an assessment on that subject, the test will be valid if it contains questions on global warming trends. So a silly example I kind of give that's an example of really bad validity is if you have a math teacher who's trying to assess your math abilities and everything, but then on the test they give you all these English and history questions and everything, things totally unrelated to math and what you've been studying, that's a very much not valid test because it is not measuring what it's supposed to measure, which is your math ability. And looking at things with history and English will not at all tell us how good you are at math. So that's bad validity. There's a couple different kinds of validity that we have, but two that you really need to know for this course are content validity and predictive validity. Content validity is the extent to which a test samples the behavior that is of interest. So, for example, with the road test with your driver's license, when you actually have to go out and drive with an instructor, that has content validity because it samples the tasks a driver routinely faces. So again, it's measuring what it's supposed to measure, how well you can actually do in that situation. Predictive validity is the success with which a test predicts the behavior it's designed to predict. So again, like some academic aptitude tests can predict your success in school at certain ages. One thing to kind of note with predictive validity is that it depends on exactly how you're looking at it. So if you look at this whole correlation here between people's body weight and football lineman success, you can see that there's generally a pretty good positive correlation here. However, when you just look at a certain range from between 280 to 320, you just look at these dots right here, there's not really much of a pattern there. They're kind of just scattered. So you have to see the whole picture here in order to get that full predictive validity. So as the range of data under consideration narrows, its predictive power diminishes. So looking at this entire graph, that's generally good predictive validity, but looking just at this small frame there, that's not really giving you good predictive validity. All right, last question for you to wrap up. Which of the following can be used to demonstrate that only about 2% of the population scores at least 2 standard deviations above the mean on an intelligence test? Which of the things that we talked about today has to deal with standard deviations and everything? I'll give you a hint. I could say, does it ring a bell? That would be the normal curve, letter E. Awesome job. So that is it. You can take a look at these last couple slides there if you would like. Hopefully that helps you to know a little bit more about how we have tried to assess intelligence throughout the years and the ways that it has changed. And I hope that we can discuss it a little bit more in class. Have a fantastic evening, everybody. See you later.